Here we are given another combustion reaction, this time the combustion of benzoic acid, whose formula is listed, and we're told that it releases 227.8 kilojoules of thermal energy, so heat energy. First we're asked to write the thermochemical equation, and so for A, we will put C6H5COOH plus oxygen gas, because it's combustion, gives us carbon dioxide, CO2, plus H2O. And we know that this reaction, we're given the delta H value, releases 227.8 kilojoules. So that'll be a negative 227.8 kilojoules for that reaction, because it's releasing energy. That negative shows that energy is being released. Okay, now we need to balance our equation. So first I will start by balancing out the carbon. So I have 6 plus 1 carbon, so that's going to be 7 carbons. And then I will balance out the hydrogen next, so 5 plus 1, so that's 6 hydrogens. So I'll put a 3 there. And then we do need to balance out oxygen, so we have 7 times 2, 14 oxygens, plus 3 oxygens, so that's 17. And then I need to balance my reactant side as well. I have oxygen in 2 places, so 2 oxygens. And then I need it to add up to 17, so I need 15 more. And that's just not going to work with whole numbers. So what I'm going to do is I'm going to put in my decimal value of 7.5, and then I'll just go back and double all of my coefficients. So my 1 here, if I double that, it becomes a 2. If I double my 7.5, that becomes a 15. If I double 7, that becomes a 14. And if I double my 3, that becomes a 6. And so now I have a nicely balanced equation with my delta H value here. I'll erase the rest of this stuff to get it out of our way so we have room for the rest of the problem. Part B says, is the reaction endothermic or exothermic? Well, since we have a negative delta H value and because it's combustion, we know that this reaction is exothermic. So there's 2 ways that we could know there, exothermic. Part C, how much heat will be released when 8.62 grams of benzoic acid is burned? So we're going to do a little dimensional analysis here. Start with that 8.62 grams, and I'm just going to write out benzoic acid because that formula is pretty long, and we're going to go from grams to moles. 1 mole of benzoic acid, if you add up the mass of C6H5COOH, the mass is about 122.13 grams. And then I need to go from moles of benzoic acid, to my kilojoules, which I'll use my balanced chemical equation for with my delta H value. So I know that for every 2 moles of benzoic acid, because benzoic acid has a coefficient of 2, for every 2 moles of this, I liberate 227.8 kilojoules, so negative 227.8 kilojoules. So when I multiply this whole thing out, 8.62 divided by 122.13 times negative 227.8, what I get as my answer is negative 8.0391. But of course I am going to need to round that to just 3 significant figures here. So the 3 is actually going to round up and become a 4. So my kilojoules is negative 8.04. And of course that negative sign doesn't mean that our energy is actually negative, it just means the energy is being given off. So there is our answer to part C. And last but not least, in part D, we just need to calculate the mass of benzoic acid that needs to be burned to produce 53.4 kilojoules. So we'll start with 53.4 kilojoules, and we need to convert to grams or mass of benzoic acid. So we're kind of doing this dimensional analysis in reverse. We're starting with kilojoules to the moles of benzoic acid. So we know that 2 moles of benzoic acid liberate 227.8 kilojoules. And now that we are in moles, we can take our moles to grams simply by using the molar mass. So 1 mole of benzoic acid is 122.13 grams. So now that we have this set up, we just need to multiply out 53.4 divided by negative 227.8 times 2 times 122.13. And that gives me 53. And actually I should start with this as a negative 53.4 because we're releasing or producing that much heat, so our negatives should cancel out. We shouldn't end up with a negative mass. And I ended up with 50. Whoops, I'm deleting the wrong thing here. Need my eraser. Let's see. Not 53, I actually ended up with 57.258 grams, which I will round to just 3 significant figures. So the 2 is going to round up, so this should be 57.3 grams of benzoic acid. And it is a long formula and a long word, but you do have to write out the substance. It is important to show what substance we're talking about since it's in grams. So there is our final answer.